everyone. Today I'm going to be expanding on our grid-based movement system. We're going to add a thing that I should have had in the first video, and we're also going to be doing a turn-based AI. So we're going to actually make it into a game, pretty much. It's not going to be too in-depth, just maybe to get somewhere before the AI does, or we could have like an AI enemy that tries to get to your position. So what we're gonna go ahead and do is open up our puppet logic here, and one thing you might have noticed already if you've already followed this tutorial, and I'm gonna go ahead and put part 1 in the description and put up a card right now, because you need to watch that first for this video to make sense. But as you can see, it's always going to go ahead and run to 0, 0, 0, basically. So in order to fix that, we want to go ahead and make our current position. We're going to go ahead and take our current position and add it to our grid system here, but we only want to take the starting position that we start with, and we're going to go ahead and add it in between our grid snap and our combiner logic. And this is actually pretty easy. We're going to need a timer, a combiner, a splitter, and a signal manipulator. And basically what we're doing here is we're going to go ahead and do 2 numbers in the combiner. And this is so we don't have to have more than one signal manipulator. I think this is cheaper, but I'm not entirely sure. But we do need to, let's see here, combine it again. So we're going to need another combiner. This is going to be 3 numbers. And we're going to go and hook up everything, just end to end, like so. And since we're using X and Z over here to get our combined, so basically what we're doing is we're combining A and C, because that's our actual direction that we want. And then we're going to go ahead and freeze that with the signal manipulator. So then we're going to go ahead and take our frozen position, split it, and then combine it into a 3 number instead of a 2 number. And we need a calculator, and we're going to go ahead and add the grid position here that's already plugged into grid snap. Let's go ahead and delete that wire. And we're also going to go ahead and add our combiner output down here. And that's going to go ahead and go into our grid snap. And last thing is our signal manipulator. This is how we're actually going to freeze the position here. You can see the freeze output button. And that's really easy. All we have to do is move the timer all the way down to 0 seconds, or 0.1 seconds, and basically we want a timer finish signal, which is the last one. So after the game starts, basically we're gonna freeze this position. So now they're gonna go ahead and move to the nearest grid space from where you drop them. So if I go ahead and make a bunch of these and move them into random positions, they're gonna go ahead and snap onto the grid from where they are. I'm not sure. Yeah, we can't really see any kind of grid system with the actual grid snap, but can kind of see it here. You can see that they're all on some kind of equidistant point. So now we have a bunch of players that are snapping to the grid. So now we need to actually make AI. I'm going to go ahead and make a simple system first, because we want to do turn-based. So what we're going to go ahead and do, and this is really simple because anything else is going to take a bit too long, I believe, but we're going to go ahead and make another microchip, and I'm just going to have it in the middle of the scene. And what this is going to go ahead and do is manage our turns. So what we're going to go ahead and do is we're going to get a selector, and whoever's turn it is, we're going to go ahead and broadcast that. So we're going to go ahead and get a wireless transmitter, and we're just going to do turn, and we're going to get a combiner, and we're going to do two numbers. So there's A team and then there's B team, and depending on which one is selected is whoever's turn it'll be. And if we go ahead and get an input from the receiver, from our transmitter, we're going to go ahead and switch the turn. So that way we only have to have the one wireless receiver and transmitter. And this is going to basically say that we can only do these inputs here if it's our turn. So easiest way to represent this would be with 2 players, since it's A and B team. So we're going to go ahead and get a wireless receiver, and I'm going to do scene for the zone size. Of course, the transmitter name is turn, and we're going to go ahead and split this. And we know we are on the A team because this is just the actual player. And we're going to go ahead and plug that into a... We're actually going to get a microchip because that's going to make this easier. We're just going to go ahead and select all our signal manipulators here for our input. And that way we can just turn it on when it is our turn. And then we're going to go ahead and take the output and use that for our signal to transmitter. And we're going to do any of the output, because for now we just have movement as our action. If you were to do like a turn-based combat system, you'd obviously want this to be more complicated, but we'll do that in a future video because we just want to have like a basic AI that will come up and chase us. So now, if I go ahead and play, you'll notice that I only pressed the button once, and now it's not my turn, so I can't really do anything. So what we're going to go ahead and do now is I'm going to make a copy of this, and I'm going to go ahead and make this version a forced possession, and the next one is not going to be forced possessed because it's not going to have the controller sensor on it. Alright, and now I'm going to go ahead and get rid of the controller sensor, and the health manager, I guess, for now. And what we're going to go ahead and do is find whatever distance the other player is. So in order to do that, we're obviously going to have to transmit this, or we could just look for player and we can find that and go to there. So that's what I'm going to go and do. So I'm going to go ahead and change the tag name on the enemy to just tag for now. So I'm just deleting all the text so there's the only one player tag. And now I'm going to go ahead and go to gadgets. In order to actually find the position of this tag, we're going to go ahead and go to movers and output, and we're going to grab a follower. And in the follower here, on the last page, there's a target position. And we can use that to basically lock on to the player tag right here in the tag name. And we want to give it 0 strength, 0 dampening, and 0 speed. That way, it doesn't actually move our NPC here. It just gets the position for us. And now we want to find out if it's our turn. And we know that we are actually going to go ahead and do player B, because this is the second team. And now we want to move towards the player. So what we're going to go ahead and do is we're going to get the difference between their position and our position. So I'm going to go ahead and get the player tag, or the player follower here. And I'm going to go ahead and get our tag output, and we want the position. So right here, the splitter, we want that translation output. And we need a calculator because we're going to find the difference. And we're going to go in third page, and we have the target position. And then we're going to go ahead and get the translation. And we want to subtract, not add. And then we're going to go ahead and see whatever number is bigger in our difference. We're going to go ahead and try to move in that direction. So in order to solve this, what we're going to want to do is, since there's 4 cardinal directions, or 4 directions, we need to figure out what direction the player would be in compared to our NPC. And then we want to decide which direction to go. So what we're going to go ahead and do is we're just going to take a look at it for now. So we have A and C that we want to focus on, because B is up and down like this, and since we don't have any height in our map, we don't care about that. And then next, let's see here. I'm going to go ahead and get a calculator just so we can see these numbers here, because they got rid of the debug thing. So we have negative on X as a possibility. We have positive and negative, and of course positive on X. So that's 4 different directions the player can be, and so that's 4 different calculations basically. So what I'm going to go ahead and do is, instead, I'm going to go ahead and get the absolute value of X and the absolute value of Z, and what this is going to go ahead and do is it's going to decide if we're going to move left and right or up and down. And then, so basically we're going to go ahead and get whatever one is higher between these two, so the maximum, and so that's going to go ahead and give us left and right or up and down. And I'm not entirely sure. And then we'll have 2 equals. So this is going to go ahead and plug into A in both of them, and this is going to plug into B, and then this one will plug into B. So this is basically getting deciding between which one is farthest. So if X has a greater distance, then we're going to go ahead and do whatever we need to do for that. And if Z has the greater distance, we're going to go ahead and do whatever we need to do for that, because the equals is actually what decides for us. And then we're going to go ahead and apply the actual negative or positive to this. So we want to go ahead and multiply this with our actual distance. And what this is going to go ahead and do is tell us if it's negative or positive. And Then, of course, sorry, I'm getting a little bit ahead of myself. We need 2 splitters, and of course this is just going to make them both into positive values, and then I'm going to go ahead and get 4 greater than calculators, because we don't want the input to the movement system to be anything other than 1, because if it is, we have the chance of moving more than 1 space. I'm not entirely sure if that's how that works or not, but hey, better safe than sorry. So we're going to go ahead and plug in all the outputs into their own calculator, and as you can see, it decides to move left. So now I'm going to go ahead and open this up because we need these inputs now. And so I am a little bit confused. Okay, so it is directly connected. Okay, so that's good. So this is positive. And this is X, correct? Yep, okay. And then this is positive and then negative. So now, I believe it should technically work. No, why did that not work? Because it didn't flash, I think. So you know what I'm gonna do is I'm gonna go and delete this, so this is always on, and this team value I'm actually gonna go ahead and get another microchip here, and I'm gonna go ahead and stuff all this stuff in here because it is kind of making a lot of different. Well, it's taking up a lot of space, basically. There we go. Closing that. And instead of turning this on, we're going to go ahead and turn this on. So that way it should pulse. Well, he is moving, but in the wrong direction. So I think what we're going to go ahead and do is just make these in the opposite, basically. Negative is negative, and I mean negative is positive and positive is negative, basically. And that should fix it. Hopefully it's also messed up on the Z. Yep, okay, so now he's trying to catch the player, and he is technically doing it. So he follows the player now. Good. Well, yeah, that wasn't too difficult, now was it? I got completely ahead of myself with this, so I was really confused about what I was doing until I clarified everything in my head. But basically, just to go over all this, what we're doing is we are getting a direction to go. That's all this is. It is quite a bit. I think there's probably a better way to do it, but this works, of course. We are getting the distance between us and the NPC, and then we're getting whatever bigger distance there is with this, and if the biggest number is equal to whatever the direction number is, distance number, I mean, then we're gonna go ahead and multiply that so we can go ahead and get on or off for that direction, as well as if it's negative or positive, so we get left and right. And then we go ahead and split that out with the positive negative, so we get just greater than 0. That way we can easily just set up the calculators in such a way. I think we could actually delete this and actually reverse this. I think that might work if we just reverse that like so, and that would save some thermometer. There's a lot of times where you're gonna have to optimize by doing stuff like that, realizing what can and cannot be done. But yeah, now he's chasing me. So that's a basic NPC. Just the following behavior. And since we have that, if anything, I think the next video I do in this, it's not really a series, but this is somebody asked how to do this part specifically, where you get it to stay in the position that you place it at, instead of going here, because all of them are, you know, they all go to the center of the map instead of staying where you place them, which is not what you want. So they asked how to do this, I explained it in the comment, and they still didn't understand it. So, video. I mean, it's not that big of a change. Just 5 more gadgets? No, 6. Yeah. Okay. Well, thank you all for watching. If you want to see more stuff in grid-based movement, like actually turn-based combat systems, more advanced AI that does something other than just follow the player, and stuff like that, go ahead and comment down in the description what you want to see, and go ahead and like and subscribe, you know. Also comment like other tutorial ideas that you want to see, because I've certainly run out of stuff to make tutorials on that aren't art related, because I'm not very good at art. I am planning on making more full game from scratch series, but I do want to make it the 3D platformer one a full game. So yeah, thank you for watching. Have a nice day. Bye.